Isaac. 9 and 10. Oh, it doesn't say turn it in, but it says get it out.
And then this one goes max.
You did. If you were here, you did it. We
Yeah,
all
mine
did
went
it.
and so it's like, if you increase the and you can add it to there you go. And then
Yes.
that way.
Hot in here.
Alex was outside.
was busy.
I thought you said you're tired.
I thought so too.
They're kind of there.
Can I go to the bathroom?
You need to hurry.
And then literally just we've just been doing like basic new stuff and slow fields.
Okay, cool.
So you practically missed not a lot.
That's good.
Mr. Townsend.
Yeah.
So I'm starting to like see like the application of a lot of the calculus stuff we're doing in physics.
That's good.
It just feels like I don't know. It feels weird because it's like I understand this stuff in calculus terms, and it's just I don't know. It's kind of weird. I see the real world applications,
That's good.
which is kind of strange. Like we were doing stuff like acceleration and velocity and position and whatnot. And I was like, oh yeah, I remember that stuff from last year. And it's like you can just like integrate and derive the different one or the other. I just found that I don't know. I just thought it was weird that I was like actually learning that stuff, and it was like way easier.
Thank you. All right. Good morning, guys, or good afternoon. So there was a handout this morning, number 11. And so this is going to be our third BC topic, and this will be one that we need to spend more than one day on, but we got to start somewhere. So I think I have it numbered for you as number 11 already. But if I didn't, please number it. All right, and so just a quick little reminder of our first two big topics that were BC only. We did partial fractions, which we will have to use again today on at least one question. The second big BC topic we did was integration by parts. There'll be one of our questions today that will need that, at least one. But now we're moving into the third one, which is improper integrals. So before I give you the notes, and before I do an example or two for you, just looking at problem 1 here, what stands out to you about this question that looks different than we have done in the past? Right, integrating specifically if part of it goes to infinity or to negative infinity. That's going to be an improper integral. So, depending on which way this goes, luckily, these questions I wouldn't say are easy, but you're going to see that the calculus behind them is just connecting a few ideas that we have. Now, we've got two different setups here. So, this is saying from A to infinity. So, this would be like include A, and then it goes forever to the right. Okay, so basically what we're going to do is we're going to change this to integrate f of x dx. So we're still going to integrate the same thing with respect to the same variable. But instead of putting an infinity here, we're going to put a variable like t. T is the most common one. And to define t, at the end of this question, we're going to say the limit as t approaches infinity. So again, instead of putting an infinity there, we're just putting a t and then slapping out front the limit as t approaches infinity. So integration is still going to be the same. The integration can be the hardest part depending on if it's u substitution or partial fractions or integration by parts. That just varies. But then we're just going to plug in t, get a value, plug in a is just a number, going to get a value, subtract them, and then at the very end we have to do a limit question. Now, if it's negative infinity to b, then we're going to do the limit as t approaches negative infinity. And instead of putting a negative infinity on our integral, we'll just put a t. And then we'll integrate that to b. b is just some number, some generic number. But the limit works how we've done limits in the past. The integration works the way the integration has worked in the past. We just have to practice enough of piecing these things together. Okay, another thing that's going to come up in here. So here's this graph. This is 1 over x to the 4th. And so remember, a good visual, or a good way to remind yourself what integration is think about it as area under a curve. So this is saying if we take all the area from 1 and go to infinity, you can see that you start adding smaller and smaller numbers, basically 0. But this area that I have in red, if you go on forever, is what we are trying to find here. So let's go ahead and we need to make good habits here. So we need to write the limit each time. So I'm going to change it to 1 to t, but I'm going to say the limit as t approaches infinity. And honestly, that's probably all we really need to know for this question. I mean, I want to go ahead and finish it, but there's nothing else going to pop up in this question. We could rewrite this to make the integration easier. So make sure you carry the limit down all the way through. I know you don't need it till the end, but if you don't write it, then you can't say equals and you're going to forget about it. So raise the power by 1. Divide by the new power. There it is, integrated. Okay, you're going to plug in t the first time, plug in 1 the next time, and then subtract those values. Minus a negative, I'll change to a plus. And then finally at the end, you've got to do this limit. So try to plug infinity everywhere there's a t. There's only this one t. So what happens to this fraction if I plug in infinity for t? Very good. If your denominator grows faster than your numerator, then that heads to 0. There's no t's to plug in here, so that's just going to be a third. So 0 plus a third gives you your answer of 1/3. This 1/3 is what that area would total up to, even though it goes on forever. It's adding smaller and smaller and smaller and smaller pieces, but if you added up all of those infinite pieces, it would be exactly a third of a unit of area. That's what we found. Okay, you guys okay with that example? So again, I'm not saying the questions are easy, but the integration we've done before, the evaluating we've done before, the limits we've done before, it's really this first part that you need to put extra focus on, how to change that. Okay, in addition to this, eventually we will get to our hardest unit in BC, which is on series and sequences. And on those questions, we put a lot of focus on converging versus diverging. So if the limit exists and you get a nice finite number, something that you could physically count to, we will say that it converges. So that one converges. But if it just keeps getting bigger and bigger and bigger and bigger and bigger and it never settles on something, we say that it diverges. Now you don't need to know too much of that for these question types, but if it converges, we will say what it converges to. If it diverges, we'll just say that it diverges. Okay, so example 2, here's 1 over x, and I want to know what does this integrate from 1 to infinity. So if I do all of this and factor in that this goes on forever, we can just integrate from 1 to t, and then say the limit as t goes to infinity of 1 over x. So integrating 1 over x is still natural log of absolute value. You're still going to evaluate the same way you have using the fundamental theorem of calculus, which is plug in a t first, plug in a 1 next, and then subtract them. But what's the natural log of 1? Okay, so let's just go ahead and change that to 0. And then not till the very, 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 very end should you be worried about this limit. If I put this in here, as I plug in bigger and bigger numbers in for t, what does this go to? Not 0. It goes to infinity. It helps if you remember what a natural log graph looks like. It looks like this. So the further you go to the right, it goes up slowly, but it does keep going up forever. So this is kind of like infinity minus 0. And since this is going to a number we cannot count to, it's going to a infinity doesn't really exist, we would say that this guy diverges. Converges is when it goes to a numerical value that could be counted to, not to infinity or negative infinity. So if you just glance at these two, questions 1 and question 2, look at the two graphs. They look pretty similar, but question 1 converged to a third, whereas question 2 just kept on getting bigger and going to infinity diverge. You can't really just eyeball the graph to be able to answer those questions. Okay, and then you do need to be aware of this. This should make one question on this worksheet pretty easy. But if it's in this format, if you're integrating from 1 to infinity of 1 over x to the p, you can just take a shortcut and skip all of this work and say that it's going to converge if p is greater than 1 and diverge if it's less than or equal to 1. You might put a star by there because that's kind of important notes that you just don't get to use on most questions. But look at question 2 before we move on. Do you see how question 2 fits the same format? It's integrating 1 to infinity, integrating 1 to infinity. What is p in question 2? And if p is equal to 1, it's going to diverge. So really, we were supposed to know this one so that we could just go straight to that. We can go straight to diverge, but there it is, worked out. Okay, now there's a couple other small tweaks that we need to do. So on example 3, we're trying to integrate from negative infinity to positive infinity. So I can change one of those to a t and do a limit as t approaches infinity or the limit as t approaches negative infinity, but I can't deal with both. So what we're going to do is what they suggest up here. We're going to split it into 2 parts. I'm going to say, let's integrate from negative infinity to some other value. 0 is a good one. 0 is just easy to work with. Plus, what to what?
0 to infinity.
Good. So again, if you phrase this as area under the curve, if I want the area from negative infinity to positive infinity, it's the same thing as the area from negative infinity to 0 plus 0 to infinity. Now we can rewrite this one. We'll do the limit as t approaches negative infinity. So we can put a t there. You really should not use t again because t is talking about 2 different things. So I'll do b this time. So the limit as b approaches infinity of 0 to b of e to the x. Yeah.
Would it not work if you just did negative t for one of them and just use t for the whole thing?
Yes, you could do that. That would be fine too. Okay, and then we need to integrate this, but what's the antiderivative of e to the x? Okay, and if I plug in a 0 the first time, I get 1. I plug in a t the next time, I get e to the t, and then subtract those. Still going to have to do the limit. Plus, antiderivative of e to the x is still e to the x. Okay, and then the first time I'm going to plug in a b. The next time I'll plug in a 0, and e to the 0 is 1. Okay, and now finally I will try to do the limit stuff. So right here I've got a 1. There's no t's, so that's not going to change. But when I plug in negative infinity to this, what does e to the negative infinity go to?
0.
That goes to 0. If you don't remember why, you might write this at the top of your page. An exponent of negative infinity in the numerator is the same as a positive exponent in the denominator, which means your denominator is unbounded, which means your whole fraction is headed to 0. So this is 1 plus 0, or minus 0. And then over here, I try to direct substitute this in. The number e, if you just keep making the exponent bigger, what does this go to? Okay, so it's infinity. And then there's no b over here to plug it into, so it's a minus 1. All that really matters in this is part of this goes to infinity. The plus 1 minus 1 cancels out, so this just keeps getting bigger. As the further you go to the right, the bigger and bigger this area gets. So all we can say is that it diverges. If you're left with infinity or negative infinity in your answer, say it diverges. Okay, there's one other catch to these, and this one is one of the harder ones, I guess, to get to. But sometimes we can do improper integrals even if it doesn't have infinity in the integral. Notice this one's 0 to 2. In question 5, we'll do negative 1 to 1. Nothing obviously wrong about those. But if we started to do, this one will have to be u substitution, and at some point we're going to plug 2 into that and 0 into that. What is the... Let's go ahead and set this up. What's the problem about 0 to 2? Okay, it's discontinuous at x equals 0. So we can't really plug in 0 into this because it's going to cause us issues. So what we will do, pay attention to this notation up here in the notes. This says include A, don't include B. So include A, don't include B. So the only way I can not include B is to have this go from A, we'll do the limit as, we'll do t. The limit as t approaches b. Now, should I be approaching from the left or the right in this question? Or does it matter? Okay, from the right, it doesn't exist here. If we're not including b, we should not be coming from the right. We should be coming from the left. From the left makes sense in this domain, from the right doesn't. So we're going to do from the left. So what's going to happen is you're going to see in question 4, we can't really plug in 0, but we can plug in 0 from the left to get by, and then that, this is supposed to be a t, and then that's kind of our workaround. Or these could be switched. We could not include A, but then include B. That's what this interval notation is saying. So if we're integrating from A to B, we could do the limit as t approaches A, and then integrate from t to b, whatever the stuff is. But in this case, should I be approaching A from the left or from the right?
On the right.
from the right. From the left, it's not even over here. So from the right. Sometimes you could pick left or right depending on the numbers. There's not like a hard and fast rule for what you need to do. Okay, so to show you how this is going to apply, let's look at this question down here. You're going to have to realize that you can't plug in 0. So I'm going to do the limit as t approaches 0. And instead of putting a 0, I'll put a t. Okay, but here's one of the harder parts. Should I be approaching 0 from the right or from the left?
From the right.
It is from the right. How do you know it's from the right?
Because,
Zero's the lower and you approach it from
Okay, that too. Yeah, you're going from 0 to 2, so you're interested in the stuff between those. Left of 0 would be outside of this. But also, I was thinking about this. If you try to take the square root of 0, that's fine. Can you take the square root of a number less than 0? Not without getting into imaginary numbers. So you can approach 0 from the right, because that's technically slightly positive, and you can take the square root of a number that's slightly positive. You can't come from the left, because you can't take the square root of a number that's negative. So there's the setup. That's the part that's new. Again, some of these you're still going to have to do u substitution. Pick out your u. Solve for du, maybe divide everything in half. You'll get to practice this a few times today, so that's why I'm just kind of going through it quickly. But there's going to be a half. Then when I integrate this, this is like u to the negative 1/2 du. Okay, so should my bounds be t to 2 still? No. Just like u substitution, regular u substitution is not changing. When x is 2, u would be 4 plus 8, 12. And when x is t, u would be t squared plus 4t. Okay, so I've got a 1/2, a limit as t approaches 0 from the right. Now I'll integrate this. I'll raise the power by 1, divide by the new power, which is the same as multiplying by 2, and that needs to be evaluated from t squared plus 4t to 12. Now notice we have a times 2 and a divide by 2, so I'm going to just let those two cancel. Okay, one time you need to plug in 12, which would be the square root of 12. The next time you need to plug in this, which would be the square root of t squared plus 4t. And then at the very, very, very end, this limit that's been carried down all the way through the end, we actually have to try to apply it at the end. So there's nothing, there's no t's here to plug it into, so this part stays the square root of 12. If I plug in 0 over here, 0 squared plus 4 times 0 is 0, and the square root of 0 is, so this guy converges to the square root of 12. The closer you get to 2 from 0, the closer the area gets to the square root of 12. Now again, it's not an easy question, and I'm trying to model this well for you, but there's really going to be two things that give you guys trouble on these questions, I think. The first is just keeping your work neat enough that you can read it. If you're jumping around, you're close to the end, and then you try to skip some steps, and then you're not sure what you did, just make sure you're writing it all out. The whole limit, do one step at a time. Don't try to rush it. It's going to take you 5 or 6 steps sometimes. And then, of course, the integration. U substitution shouldn't be too hard, but again, I think one of these today will be partial fraction, one will be integration by parts. So you might want to look back at your notes for those. But it will be a great opportunity for you to see if you actually recognize those without being told as well. Okay, so last example, and then I will help you get the first one set up. And we'll do we'll go over the first two together on the next page after you try them. Okay, so I can look at this and I can tell this is going to be an improper integral, because if I integrated this, this is going to be natural log of x, and I can't plug in 0. 0 doesn't exist, and 0 is between -1 and 1. So we could split this up and say, let's integrate from -1 to 0 plus 0 to 1. It's important that you understand those are equivalent. The area from -1 to 1 is the same as the area from -1 to 0 plus 0 to 1. Now again, I still got this problem with 0, so to deal with this 0, I will change it to a t. Okay, and should this be as t approaches 0 from the right or from the left?
The left.
I don't think it's going to matter in this question, but if this is like -1 to 1 and 0's the problem, I would say go from -1 to the left side of 0 first, and then on this one go from 0 to 1 and go from the right side of 0 on the next one. Again, sometimes it doesn't matter. It really just depends. Okay, I shouldn't call this t again. I'll use b. Okay, but 1 over x integrates nicely. Natural log absolute value of x. Make sure you do the absolute value, because otherwise you're not going to do with the negative. Over here, this is going to integrate nicely. Natural log absolute value of x, and it's from b to 1. That was a t. So over here, the first time I'm going to plug in a t, then plug in a -1. Absolute value of -1 is +1, and the natural log of +1 is 0. Over here, I'm going to plug in 1 first, which would give me 0, minus plug in b. And then now that I've integrated and evaluated, the last thing to do is to get rid of this t and b stuff. So I need to try to plug this in, and I need to try to plug this in. And I misspoke on this one. This one really should be from the right. I'll tell you how I know that now. From the right, from the right. Because when I plug this in, the natural log of 0 does not make sense. That's why we need to approach it from the right or from the left to fix that. But what is the natural log as you approach 0 from the right? We did this already, right? We talked about the graph of natural log. The reason how I know it's not from the left now, I really thought it was from the right, but it doesn't come from the left. Like, it does not exist over here, so that doesn't make sense. From the right, as you approach 0 from the right, this approaches -infinity. It goes down forever. Plus you got a 0, plus you got a 0, and then minus. If I try to plug in 0 here, this doesn't make sense, but 0 from the right is the exact same thing. 0 from the right is approaching -infinity. So all of that cancels out, and we end up with 0. You do need to be careful trying to combine infinity and -infinity. Those don't necessarily go to 0, but they do in this case. Now, there was a lot easier way to do this question, and obviously we need to practice the calculus, but just to try to make a connection for you, do you know what 1 over x looks like? Do you know what that graph looks like? Okay, I'm seeing some hand stuff. I'm going to guess y'all are doing it like this, right? Some point in Algebra 2, you memorize that for parent function. If I want to know the area from -1 to 1, you see there's some area here. How does the area here compare to the area there? It's the same, but this stuff is positive and this stuff is negative, right? So when you combine those, where are they going to go to? 0. So that makes sense.
Like in what cases do the infinities not cancel out?
It would just depend on how quickly they're going to infinity and how quickly they're going to negative infinity. This question's not a good example of that. If one's going to infinity super fast and one's going to negative infinity fairly slow, then it can complicate things. But these are exactly the same thing. So it says this one was minus a negative, so it became plus, and this was a positive, but they were the exact same thing. They were natural log of 0 from the right, so I knew they were going to cancel out. Also, just knowing what that graph looks like and thinking about the area, I realized it made sense to be 0. Okay, so the first thing I'd like you to do is on question 1, I'm going to give you 60-second head start, and I would like you to try to set it up. Just try to do the setup of question 1. And in 60 seconds, I will show you my setup. And then you can correct yours if you need to. And then I'll give you 60 seconds to try the setup for number 2 also. Then I'll give you time to actually work the 2. Okay, so for question 1, you should have rewritten this to say the limit as t approaches infinity of 1 to t, keep everything else the same. Instead of saying infinity, say t, and put the limit part out front. Okay, and then in just a couple minutes, I'm going to ask you to try question 1. You should end up with an answer of 1. So jot that down so that you know if you did that one correctly or not. Okay, try to do the setup for question 2. Just the first setup, how to rewrite it so that it looks like stuff we know how to do. Okay, also this one, pretty much the same idea. We don't want to leave infinity in the integral, so we'll change it to a t. At the end, we'll do the limit as t approaches infinity, and then all of that is going to be equivalent to the original question. So I'm highlighting the part you're trying to change and how we are dealing with that change. Everybody okay with how I set those 2 up? Okay, I'd like you to go back to question 1. Now actually integrate it. Plug in t, plug in 1, do that fundamental theorem of calculus, and then try to do the limit at the end. So try to come up with an answer of 1 for question 1. Okay. If you are not getting an answer of 1 for question 1, then let me help. Yeah. Sign out and take the pass. You might want to, instead of saying 1 over x squared, you might call it x to the negative 2. I know it's a pain, but you need to carry this down the whole time. That's important if you want to say they're equal. And it's important that you don't forget it. So to integrate this, we can raise the power by 1, divide by the new power. Instead of calling this x to the negative 1, I'm going to call it 1 over x. Same thing. So first time you plug in a t. The next time you plug in a 1. Subtract those. And it should look like that. And then at the very end, you try to do the limit. And negative 1 over infinity goes to 0. So the answer to this question comes from 0 plus 1. You guys okay with that part? Okay. Looking at question 2, we think about our integration techniques. This does not look like one I have memorized. Does this look like U substitution? Okay. What else could we try?
Partial fractions.
Very good. If it's a big fraction, especially if the denominator factors, remember we can change this with partial fractions. We can try to figure out some number over x plus 3 plus some number over x plus 1. Now, I am going to help you with this one. I'm going to go over this one with you. But I want you to give it a shot first, because I want you to finish trying the partial fractions. It's going to split it up. You're going to see it's kind of hard to keep up with your work. And at the very end, depending on how you write your stuff, you may get to this answer or you may get stuck near the end. And that's why I want to make sure you don't get stuck at the end. But if you're feeling pretty good here and you end up with an answer of natural log of 3, then you did it correctly, and then you can keep on going. So again, this one's going to be on the harder side because the integration's a little bit harder. And it's certainly going to be messier. I don't think I gave you enough time to finish 2, but that's okay. Because again, like I was saying, at the end of the question, I'm a little concerned that you might not be creative in the way they expect you to be creative. Okay, so here's the partial fraction stuff. You can see I said this fraction equal to linear smaller fractions. Solve for a and b. So we could do a over x plus 3 plus b over x plus 1. Okay, both parts of this are pretty easy to integrate. This would integrate as negative natural log absolute value of x plus 3. This integrates as natural log absolute value of x plus 1. Neither of those have chain rule, so we don't have to do u substitution or anything like that. We need to evaluate from 0 to t. Now, here's where, I don't know, this is not the easiest thing to see, but can you see how I can condense these two? Let me switch the order of the terms. If you have two natural logs that are separated by subtraction, how can I condense those into a single natural log? With division. I'll scratch out question 4 for a second so I have more room. Okay, so one time you're going to plug in t into all of that. The next time you're going to plug in 0 and subtract them. Natural log of a third. Okay, here's the part that I'm a little concerned about. Well, first off, I didn't think you would think to condense these. Now that they're condensed, if I try to plug infinity in for t, what does this head to as t gets bigger and bigger and bigger? Very good. How do you know it's 1? Well, infinity over infinity can be lots of things. Right, if you think about your horizontal asymptote rules, these both are degree 1, so they're basically growing at the same rate. So you could do leading coefficient over leading coefficient. So really all of this is like 1 as t goes to infinity. And what's the natural log of 1? So one way to say the answer would be natural log, or negative natural log of a third. But depending on how you approach it, you might say this. These two things are equal to each other. If you got this as an answer on a test and it was multiple choice and that was the correct answer, how can I play with this to make it look different? Okay, that works too, yeah. She's saying pull this up as an exponent, and 1/3 to the negative 1 is the same thing as 3 to the positive 1. So that works. That's actually easier than what I was thinking. I was thinking about expanding again. This is like natural log of 1 minus natural log of 3. This goes to 0. Negative times a negative gives you a positive. So there's a couple different ways you could rearrange that if you had to. So again, the part that's new, the part that you have to make sure you understand is this setup. Changing infinity to t, and then throwing this limit part out at the very end so that it deals with that. I can't help, some integration is going to be harder. Some integration is going to be u substitution. Some integration is going to be partial fractions. Number 4 is going to be integration by parts. So if you don't have that formula memorized yet, that's okay, but you might need to get out your notes and look at that one. So this time I'm going to get out of your way a little bit because you're probably all at different places now. But if you want to go ahead and try question 3, 3 only needs u substitution. And I'll share the 2 answers from this one. I went ahead and jotted them on the board there for 3 and 4. So of course, if you're not getting those, you need to try to compare your work. I do have all of the solutions with work on the website. Now, it's not my work, so it may be a slightly different approach than what I told you to do, but it should still be fine. So feel free to use that also. But give them a shot, see how they go. You get stuck, try to find your mistake, really try to put some effort into moving forward. But when you get hard stuck, work with your neighbors and or ask me to help out, please. Go ahead and jot these two answers down so I can switch the screen back to the agenda, please. Square root of 3 is what we're aiming for on question 3. 2 over e is what we're aiming for on question 4. Okay, part of why I wanted to put the agenda back up here is when I was looking back over this yesterday, I realized that you guys might want to spend a little more time than just today on this. So I did move our quiz from next class to the class after. So there is no quiz next class. We'll have more than just today to worry about these. I just felt like this would be worth 2 days of, not just 1 day.
So right here it's saying arctan approaches negative infinity. That means the slope approach negative infinity.
The ratio is approaching negative infinity. It's an inverse function, not a regular tangent function.
So that means it's asking for the...
It's asking what angle would give you a tangent value of negative infinity. Do you know what the tangent graph looks like?
It's like lines.
It's
like,
lines, okay.
Basic or like detached.
Detached lines.
Well, not lines, but like, you know what I mean.
What's the tangent at 0?
0.
Okay. What's the tangent at pi over 4?
1.
What's the tangent at negative pi over 4?
Negative 1.
Okay. So that kind of helps you see. So here's where it's going to negative infinity. When tangent's approaching negative infinity, it's got an angle of negative pi over 2. And when tangent's approaching positive infinity, it's approaching an angle of positive pi over 2.
So that would mean arctan of...
Arctan is inverse. So inverse.
Yeah.
So if you're doing this, it's saying what angle has a tangent of infinity? That would be pi over 2. If it's arctan of negative infinity, you should give the angle that gives negative infinity, negative pi over 2.
Okay, so arctan of infinity would be pi over 2.
Correct.
And then arctan of negative infinity would be negative pi.
Yeah. I think your issue is the inverse here. Tangent, a regular tangent is when you plug in an angle and you get a ratio. Inverse like the cat eating the fish. The input changes and the output changes. We switch the input and the output. And arc is the same thing as inverse. So.
But wouldn't like the arctan in negative infinity also be equal to like 3/2 pi?
I know why you're saying that, but no.
Is there a reason why?
Yes. Inverse trig functions have agreed upon restricted trig functions have agreed upon restricted domains which create restricted ranges of inverse trig functions.
So from negative 2 pi to 2 pi is the domain?
Inverse tangent, the range of inverse tangent is negative pi over 2 to positive pi over 2. The answers always have to be between those two. It's just an agreed upon mathematics thing.
So then for inverse sine and cosine, what would the domains be?
Inverse sine is negative pi over 2 to positive pi over 2, but it includes the points. Inverse cosine is 0 to pi.
So it doesn't include the other half, just 1/2 of it?
Right. You want, the point of restricting those is to get one value. When I say inverse tangent of 1, everybody needs to have the same angle.
Right.
We don't want some people saying 5 pi over 4, some people saying 1 pi over 4, some saying 9 pi over 4. We want one unique answer.
Okay.
So
That makes sense. Thank you.
we do this in pre-cal, but in pre-cal we spend like a week and a half, and they have to memorize those. So I don't know that anyone remembers them anymore, but
Oh, yeah. It was. Which one was that one? We had one. We had one last year. It was Labor Day. We didn't have
yeah.
I never got my homework back from my last Friday for like the u prime minus integral or like.
Check the box over there.
Oh yeah.
Were you gone that day or something? Okay, I should have put it in there then.
Mr. Townsend, I'm not going to be here on Friday again.
Okay. We're going to be spending more time on this type of problems.
Oh, okay.
So,
I swear.
what is this Friday?
More away games.
Don't you sign up for that? By doing
Kind of.
or whatever? Why is this in the non-meeting?
So I got the correct answer. I don't know if I caught it, but why is it that you gotta do discontinuous or whatever? Sorry, I just
Yeah.
He's like, I did it the same as the example one, but like I don't fully.
No, it's fine. It's just that the answer it can vary depending on the question.
How to use
So
use that.
I don't understand what's yeah, it doesn't
you
exist.
can't plug in 0 at some point. You've got to plug in from the right. And
Like I can't put 0 in like. I have to integrate this.
That's not changing it, that was just.
Oh, never mind.
When you integrated it, there were. Well, we don't even use.
Oh, you're right.
Yeah, so.
Do we like math?
You just need to.
With 2 over 1 cancel, right?
Yeah. I think you're gonna get the same answer whether you do it from the right or not in this question. Like somewhere in here, and I can't identify where, but
Did you do negative?
it seems like you should be able to take, just plug in 0 there and that'd be fine, but it still goes to 0. So I don't know. I can't tell you why that one's improper. I think if you just did, it normally, you'd still be fine on that question.
Oh, I thought it was proper.
Well, it probably is, but I don't, nothing wrong with the word. I can't see where you can plug in this, but I think that's it. So to fix this, it just looks right. I know that's not a satisfactory answer, but sometimes it's hard to see why you can't plug in certain diagrams. Like infinity or negative infinity is pretty easy to pick out, but then a lot of the times, like, you know, on this one, if this was -1 to infinity, you probably need to get 0 too, because it looks like it would be division by 0.
Yeah.
So,
And did you say there was anything about this one that happened? Like,
well, how do you integrate when it's something times something?
oh, like backwards.
By parts. That's why I was saying you might want to look at your notes since that's pretty new to you.
Oh, well, this is different.
Hi. I will let him know. Right now? Okay.
Oh, you're right.
Camden, they said you were checked out when you finished your math work. I'm just kidding, you're checked out now.
Yes.
I thought it was supposed to be the negative one. Right? And that way, I mean, this might be
Yeah.
just it's not negative.
Okay, well, right here, this u to the -1/2 integrated. Here I have. So I just undid power rule. I raised the power by 1. And then divided by that, and then that's where they went half.
Unless it's really it's like X times
Yeah, so you're just ignoring that you haven't done anything. Raise the power by 1 first, and then divide by a half. So it's going to be 2, this one.
Yeah, and just plug in T, and then plug in. Plug in T and then plug in.
That's 0 though, right?
I don't have an issue with the word, but I might have to come back and say sometime. I don't know if I've seen these on FRQ. So my only concern would be on an FRQ, you might not be showing the steps.
Well, I mean, instead of writing
Subtract E to the -2 minus 1 over E.
If this was an FRQ question, yes, I think we can.
Yeah, but the first two would become 0. So those two are
The problem is, there's not a real angle that has a tangent to infinity. There's an angle that approaches infinity, and that's where limits allow us to say it really approaches. But we plug in infinity and negative infinity for convenience to try to wrap our head around it. But you can't really plug in infinity. You can take the limit of something approaching infinity of t and then put a t there or whatever.
So mathematically, we're zero down. Just make sure that you can do it.
Well, if you put these into this, you just get these to the one. But if you leave these as one, and you
Go on, click. Make sure you check with the website. The answers and some work to all of these are on the website. You need to be using that to make sure it's right and to help catch some mistakes as you go through
Should
it.
tell my computer does this. I can't check my
I have to do it for homework.
but those two goes to zero.
Bring and charge your Chromebook every day.
No, I had it charged, and then it kept dying. It kept like draining.
These are a lot.
Because it was at 100 this morning, and then my second period it was at like 20 for some reason.
Bring your charger with you. Charge it when you can.
I'll do that.
Which is infinity. I mean, your teachers are gonna use your Chromebooks a lot this year with no phones, so.
It's not my personal.
Personal. As far as I know.
It's not even like that.
That's what we got right here. Oh, yeah.
They're just like faithful to.
This goes to zero. This infinity over infinity. Over E.
Was that crazy?
Yeah, what is infinity over E?
Okay, if this,
That I don't know.
if this is zero, this is, then the infinity
From zero to. It's bigger than yours, like very fast.
which is
Wait, what's negative infinity times zero?
zero.
No, that's okay though.
That only works
You're right,
with
you're right. It has to be
zero,
greater than zero, yeah.
Yeah.
It has to be less than, sorry, less than
Okay.
zero.
I'm not
Or
disagreeing.
equal, less than or equal to zero.
So you got the right.
So that way you just gotta.
2 over E? What about it?
So you
What
use
is the
that.
question? No, I've got the answers online for you to check.
Same thing.
We're gonna have to do that on one eventually anyway.
Somehow I'm getting negative 30.
Negative 30, or, I'm sorry,
When it should be square root of 6.
You got a lot of time. It's only Monday, you have the whole week.
What happens with this half?
Period. The one half is right there, one half.
Okay.
Well, he didn't have to integrate because he just either.
2 times 9.
No, it's not.
2 times 15.
What's on top? So long.
Oh,
0.
oh, I see, okay, no, never mind. I was gonna say, you didn't do the 1/2, but you did do the 1/2. 0 to 1, okay.
Yes.
Okay, so you plugged the 3 into this, right? And you got
9, 6.
I wanted to say it times
wait, there's your problem. You can't do 15 times 2 to raise to the 1/2. You gotta do order of operations.
Oh,
Exponent
X
comes
and
before
X.
multiplication.
Okay, so 15 to the 1 half.
X times X plus.
Yeah.
That's X squared plus X.
Why don't you just let this 2 and this 1/2 cancel,
No.
and then you don't have to keep up with either one of them.
Yeah, so they cancel, and then you have.
So then that 2's gone now.
I think that's. And then you have 15 to the 1 half.
Okay, so the
So
square root of
it's just a
15.
factor,
And
right?
then you plug in 0, you get 0. Okay, what did I say, 3? Okay, let me look.
X plus
I don't see your mistake.
1 X. So you just divide by X. What number is that, 3?
X times X plus whatever.
I didn't even do any of that.
Well, technically you can't plug in 0 into this, because you're gonna have, I'm not sure where, but
Part, you can't plug in zero, that's what's making it imperfect correction. So that's where I just changed the 0 to a 2.
Yeah. That might be throwing me off.
Well, you don't have the limit, so in the end, me plugging a 0 into this, it's the same as that being 0, so I don't think that's a problem.
Oh, what's that?
That would be the square root of x squared plus 2x. And then the square root of t squared plus 2t.
Oh, okay, I know what you did. So you did u substitution, this is in terms of u. You changed the bound to be in terms of u, right? And then you plug x's back in.
You're right. That's
0 to 3 makes sense for u, but 0 to 3 doesn't make sense for x's.
So I would keep it as
You can either
0
keep
to
it,
1.
you can keep it 0 to 1 if you're gonna stick with x's, or you keep it 0 to 3 if you're gonna stick with u's. I would do this, this is gonna be the easy one to integrate. Or, you already did integrate it, my bad.
It, yeah. So I would evaluate it 0 to 3.
You really should put the evaluation like over here to the right though. That looks like you're saying integration, integration not very straight. So when you plug in a 3 into this, you get the square root of 3.
Yeah, that's what
Right.
And then you plug in a 0, you get the square root of
It's
0.
like, as
But then you can't,
Get square root of
you
0.
can like change the zero.
So the only issue is you change your u to x.
So what'd you
can
do?
Yeah. But you have to change your bound back if you're gonna do that.
Miss Cross.
no, arctan is 0 is just like.
That's the way she did it,
It
whereas
is?
you do it the other way. And that's
Cause
what
like the slope is,
I've been doing it.
Yeah, well, you can do it either way. I just always do u's
No.
and u bounds, and that's the only way I do it. Just for consistency. But you can switch them back to x's if you want to. Just don't do
Because
some of
arctan
one,
is
some of the
0 is
other.
just 0.
0. So 0 for 1.
For some reason, I thought it was 1, 1, and 0, which would not make sense.
Mr. Thompson.
Yeah.
So, this is the limit here. So from 0 to 1, right? Like if you look at the graph of this, it looks like it would go to infinity, right?
No, because it gets smaller.
No? What goes from 0 to 1?
Yeah.
0 to 1. This is the graph.
Yeah, but I'm saying what you're adding here gets smaller and smaller and smaller.
What do you mean? Because like if you go up, it should be like
So
infinity, because this goes to infinity.
I'm saying there's some area here, and then there's less and less and less and less and less and less areas and less and less. And then basically none. So it doesn't that area doesn't necessarily go to infinity.
It doesn't?
Now, look at these two examples. These two almost look the same. They were both from what? 1 to infinity, 1 to infinity, and we were doing this area here.
Oh.
But this goes forever, whereas this approached 1/3. So you can't just reason your way into what it's going to be.
But like when I did this, I got as t approaches 0, 0 minus natural log
Yeah, you
t.
just flipped.
And I don't really know what that is.
This is so stupid.
It says determine all values for p for which that converges. And I was trying out different exponents.
Trying to see, I thought that was in the notes somewhere. Okay, where'd your P go?
I just tried to substitute p equals 1. Or is that not what I should do?
You need to work it out. You're gonna be left with a statement that has P's in it,
Oh.
and what's left behind
You can get a semester.
should match
I think you can get a semester for
where it's talking about this format. So then you can figure out what P needs, what range P needs to be in.
Okay, thank you.
Is it that? No, but like what was my problem? I mean, you could just explain
Oh,
that.
yeah.
That if it was
They
less
don't
than
work
one,
out
then,
together sometimes.
then.
Then you can't keep up with it, huh?
Yeah, I'm sure he did too.
Right.
That's great. That sounds like Jackson.
Oh, then you could just,
He's bragging about himself.
you would just show the last.
Well, I don't know if he's bragging about himself.
No,
Maybe he
no.
was just saying you weren't on his
Right.
level or something.
Did he really say that? I knew you were making that
But
up.
I told him I was gonna tell you that you were saying, he said you're a week or something.
No, Jackson would never say that. Jackson's like super humble, super nice.
I told him I was gonna tell you that to stir up trouble.
Yeah, I figured that's what you were
Pretend to
doing.
be mad at him if you want. How's it going?
Cosine is 0, 1. Dang.
Is it Denison or?
0.
This one's gone.
So this goes to.
Okay, so. Okay, you're missing a plus or minus sign. Report integration.
Yeah. What over here?
Integration bug bars.
So this is it.
Get the negative 1 over 4.
You can still.
Wait, so
Plus
you were-
The less.
And then you can evaluate the whole
But
thing.
if you graph this,
This will be.
Oh.
you graph it.
So you're on the right track, you're like right about here, so you still need to do the antiderivative of that. Then you can evaluate from 1 to t, and then you can do
This. Wait, no.
Or negative 12. But I don't know how, but when you drag it like this, like it's different. There's on.
I'm just trying to get a gauge of where y'all are at. How's it going?
Yeah, but.
Hold with it.
Yeah, I just.
1 second, Jay. I need to put this in for her. and I forget.
Oh, and then, yeah, you could.
Yeah. Wait, when it's coming from the left. Yeah, because, so this is the graph negative.
So that means that's
where it's
negative.
four.
It's like a look,
But,
but
like,
then.
if it's coming from the left, it's like, going like this. But there's some.
4.
Going down.
But I just did 4.
I just don't know what.
And you checked it with the website.
So you just didn't do partial or by parts?
No, I did, I just didn't write it down. I'm real tired, so it might not make a ton of sense.
But I just checked with the website.
Yeah, that's probably a better plan.
I am very tired as well.
Well, like I said, those are not mine, so that didn't help me too much. Okay, so this goes to 1. Adding the 4th. Okay, what did I get?
Oh, right here. So you tried to plug in 0 into this, right?
Yeah.
So negative, well, 4 times 0 would be 0. Negative 1 divided by 0 is, well, it's not 0. To get 0, you gotta get 0 over some other. So it's either going to infinity or negative infinity. Yeah, so that's why. But at the end of the day, if you've got infinity or negative infinity stuck in your answer, just say that is.
Mr. Townsend. I don't know if I did
I don't know if I just like
the part right.
What part?
You already know the cases of
I don't think I'm gonna have time to check.
There's like.
Are we out at 105 or 305?
It's like.
3:15, we do it.
315?
Yeah.
Okay.
Yeah.
We got about 15 minutes. What happened to the rest of this? Wait, but did you do the limit or not? Because you're saying the limit's not done yet. Okay.
But like, I don't know.
It's 1 to
When it's 1 over
There should still be an X in there.
So you just say P is greater than.
infinity.
I'm sorry, not P is greater than.
Because that, we plugged in
Your
the.
exponent is greater than.
With that.
And that's.
So then rather much.
With that. Minus that. This should be an X.
An X? But like, we put
Oh, you, okay, so that's after you plugged it in. Okay. So that's 0.
And then what is
You're still missing something. You're plugging in 0 for T. Where's your T? I see, I don't see a T here.
I put the T over here. And then I
Okay.
put it.
1 minus.
Just like it for.
Wait, are you plugging in T for P?
Okay, well, okay.
No, I'm plugging in T for X.
Okay. That was fine. Still have something to say.
Chain rule. Crap, I forgot about that.
You said about every single teacher. No, I didn't. Said about Mr. Okay, got it. Shall we learn that job? Or perhaps.
Yeah, so my issue is here, you should be plugging 2.
We should do that. How do you read?
Positive P, negative.
What's the version?
Positive. You should still have an X in here somewhere.
Okay, so looking at the letters and
No, I know what you're saying, but I didn't ever evaluate my limit, whereas you did, and that's where it's hard to match it up.
Cause I don't really know how to determine how it contributes.
Yeah, I need to look back at this one. Skip it for just now, because most people aren't that far anyway. Plus the next 3 are, 2 of those 3 are actually not too bad.
I don't know.
Well, I need to redo one of my questions, so give me just a second.
Oh wait, no, English. Oh, wait, it's X negative what values negative things like that. And that's why I inverse basically means like if it's
I don't think you're supposed to be.
no, inverse basically means like inverse pi over 4 is like what value gives you pi over 4. So inverse negative 1 would be square root of 2 gives you inverse negative 0 is 0 because at 0 degrees yeah.
Every single class. They cover so much. There would be so much.
Wait, are you?
You purposely get yourself banned from one. Did you get it? All the violations.
I mean, I understood all this. I don't know how to paint in zero.
Like show it by using. But like. I just said, I just said
I was just like,
undefined. You don't have to.
Yeah,
I don't
no, I don't know.
How do you?
I think you just because it's like in between.
Just show that
Yeah,
there's a
because there's a asymptote.
What is it on?
What?
Because
You start at me.
What is that?
I leave school.
I mean, you already said it's the same thing.
Bounded means like this, like all the areas trapped. Unbounded means like some of the area goes on forever. That's the difference between bounded and unbounded.
And I'm gonna do a German see if
It's still bounded.
No, because it goes on forever. There's a little bit of area forever. That's unbounded.
So what is trying to find?
So if it's greater than 0.
R is the unbounded region, so it's area of this between the x-axis and x is greater than or equal to 0. So you're trying to find area. So if you're trying to find area between the function and the x-axis, you need to integrate that.
From what to what?
This is 30.
Well, from
Yeah, this is the third
when it intersects with the
So it should be
x-axis.
2b be a row.
And to the infinity.
I only break
2
up
to infinity? That I don't know.
twice. Let's go.
I did
No,
0 to
3
infinity.
times. Because my
I don't know where
battery
you're
sections have been moved to Thursday 0 hour. So I have 0 hour 8 days and then Thursday 0 hour as well. So some weeks I have 4 0 hours and 1 regular day.
It's a lot.
That's gonna add up after a little bit.
Yeah. Yeah. I don't happen to do bad.
I'll still do good in my 2 classes I'm taking besides band.
When do you have to wake up for that?
5:45.
Well, that's not too far from when I wake up. I wake up at 6 because I have to drop my brother off at school.
I usually get up at like 6:30.
That's what I was saying.
Yeah, I wish I could.
I get up at 7 on B days
If I didn't have to take my brother to school, I would probably wake up around 7.
I had to wake up at like 6 every day last year. 6 or like 5:45 or so. But now I get up at 7 on B days. Well, on B days I don't practice. I go here, I do band, and then I go home.
Yay!
On Tuesday. And I guess some Fridays that are coming up.
But not any
Not Thursdays. Because I got a rehearsal, and then I got a rehearsal for second period.
Yeah.
And then I go to work.
I don't.
You know, I'm not mad, I just started my job, so it's like, whatever.
Yeah. My internships hasn't started back up yet.
I'm not mad I have my job on new 0-hour days. I'm mad that the new 0 hours are my job day. Mostly. Because I would rather do my job than more band at this point, in all fairness.
Interesting.
Because we have 2 3-hour rehearsals every week.
Yeah. I mean, these jobs make money.
Yeah, but like we got all the rehearsals, all the early rehearsals, and then we got 2 3-hour rehearsals on Tuesday nights and Friday nights that we don't have football games. So it's just like, we literally do, I guarantee you, we do like 12 hours of band a week.
That's a lot of band.
It's very annoying.
Okay, I need to give y'all a stopping place here. So, I do not expect you to try to finish all of this up for homework. However, I would like you to stick with and try again and feel pretty good about the first 6. So, if you feel pretty good about the first 6, then you don't have homework. If you didn't feel pretty good about the first 6, then retry a couple of them. Keep going till you do the first 6. And then we can worry about that in next. You will need to do all of them, but you need to be comfortable with the first 6 before next class.
Yeah, this is going to be on the quiz.
It will be, but we're going to do more practice on it. Did I show you this logic puzzle already?
Yeah, that was last time.
Okay, here's today's logic puzzle if you're interested. Somebody did come up with a pretty good answer pretty fast in third period. Or first period. I don't know if that's the real solution, but what they said surely made sense. I did post the answer and solution to Google Classroom if you want to watch the video. I think it's only like a 3 or 4 minute video. It's not as long as some of them. Okay, what would you do?
Would you like give it like 2 bottles, wait for them to take effect? If none of them do, then do one of those and then...
What if it does take effect? You don't know which one it is.
Yeah, but you know it's one of those 2. And
Yeah.
so, and you've got another 10 hour
That's a better
period.
odd than if you gave it like 3
And then you can
bottles.
test.
And then your rat is dead.
Oh yeah.
Oh, you do only have 1 rat. But then you've only got a 50-50 shot of dying.
Yeah, but if none of them take it...
I would prefer to have a better than 50% chance of dying. Yeah.
Like, like test the first bottle of milk
Yeah.
immediately, then wait an hour, and then
Yeah.
test the second one, wait an hour, test the third, wait an hour, test the fourth.
Okay, how's that let you know which one
Because then
is...
it's like, if he
Because they're
dies
staggered.
after, if he dies at the 10th hour, it was the first one. If he dies at the 11th hour, it's the second one.
Because they're staggered.
That's what somebody first period said. That seems to make sense to me. But I don't know that poison would kill them at exactly the 10-hour mark, but yeah.
And this
Depends on the poison.
And this one it does.
It really depends on the poison.
Okay, yeah, that makes sense. Could you do that for all 4?
Yeah, you could
Just do all 4 and then
stagger all 4.
Yeah.
You would know
depending on
based
when
on
he dies. Now maybe the puzzle should be how do you survive and the rat survive?
You don't
that
take
even-
the, you don't
But it says you have to do it.
It might make it harder.
unless you tell me to skip that. Just for you to skip. You don't want me to skip. Silver notes. I'll skip it after this.
But it's a performance grade. It's not a change. It's, that's the